Okay guys, here we go. This thing is called log properties and conversions. Okay, so if you have a logarithm, we talked about this, log is a base function. So it's got this weird little number on the bottom, whatever it happens to be. I'm going to say log base 3. Log base 3 of, let's say, 9. It equals 2. I could punch this in on my calculator if I want. I could say log of 9, and my calculator is going to put up the parentheses, divided by log of 3 if I want to trick my calculator into base 3. And it will say 2 when all is punched into the calculator. But see, here is the thing, and I've said this in earlier videos. This is based on the fact that any log statement can be converted into an exponential statement. The key is this. There's a base value. So in either format, the base will stay the base. What's going to happen next is I'm going to interchange these two values. So I'm going to put a 2 here and a 9 here. 3 squared is equal to 9 is the exponential version of log base 3 of 9 equals 2. So if I said 2 to the 4th power equals 16, this number here would be called the base. The thing being taken to the power is the base. So if I wanted to convert this into a log statement, I would say log base 2, base stays the base. Then I would interchange where these two guys are located. I would put the 16 here. It would equal then 4. This statement, 2 to the 4th equals 16, that's called exponential form. And over here, well, guess what? This is called logarithmic form. I'm just going to abbreviate because I'm running out of room. Log form. So the first thing that I want you guys to practice is just going from form to form. So let's suppose they gave me something random like this. 3 to the x. 3 to some power equals 81. Well, I'm not asking you to guess the answer. I'm saying, which form did I present the original in? I presented the original statement in exponential form. That's an exponential form statement. Could you convert this into a logarithmic statement? And just remember, when it's exponential form, there is no log. When it's log form, there is a log, and it's got to have a base. So the base would be 3. And if I wanted to convert this, it would say log base 3 of 81 equals something. I'm not asking you to tell me that x must be 4. I'm not asking that. I'm just saying, could you convert between the two formats? I started you with exponential. Could you write it as a log form? So this is actually not a tough thing to do, but it's a really important skill because sometimes you're looking at a question and you don't know what it really means until you convert it. And then when you convert it into the other format, you say, oh, I could do that easily. So what they're going to do in the book is they're going to show you different problems. I'm going to start you off with exponential form. So they might do something like this. X to some power equals 16. They're not asking you to tell them the answer is 4. 4 squared equals 16. They're not. What they're asking you to do is, can you convert this into a logarithmic statement? And the answer is sure. I would say log base. What's the base over here? What is the base here? It's x. Then what do I do with the other two values? I always interchange them. So I'd say log base x of 16 equals 2. This would be the logarithmic version of that same statement. We're just converting. So they might say something like this. X to the a equals 4. And they say, can you convert that? And I go, sure. Until I know what x and a are, I have no idea what to do algebraically, but could I convert it? Yeah, I could say log base x, then I'd put a 4 here, and I would say equals a, because to convert between logarithmic and exponential form, you have to remember this. Whatever the base value is, the base stays the base. It doesn't change. Whatever the base is going to be the base in either format. What do you do with the other two pieces of information? Base stays the base. The other two pieces, flip-flop. Base stays the base, comma, flip-flop. That's how you convert stuff. Let's do one more. What if they gave me a statement that says, oh, I don't know, 4 to the negative 3 equals x minus 7. And they say, can you convert this? And I go, sure, if I wanted to convert it. I'd say log, what's the base? Base is 4. And then what would I have to put here? I'd have to put x minus 7. What's it going to equal? Negative 3. Now, I did this kind of sneaky. See how I stuck that thing into parentheses? Because I would be interchanging this with that. So I'm treating this as one piece. This would be one piece. So I'm just being a little sneaky. But can I convert? Yeah. Base stays the base. What do you do with the other two pieces of info? You flip-flop them. So what about this? E to the second equals, I don't know, y. What if they gave me something like that? And I said, okay, well, what thing is the base here? The base is the base. It's e. So if I was going to convert it, I would say log base e, and then flip-flop of y equals 2. To convert, it's not hard. But this is not the answer you would see in the book. The answer would be natural log y equals 2. Here's the thing we got to remember. We never write log base e. Log base e has a very special name. It's called natural log, and it's even on your calculator. There's a button that says ln because we use it so frequently. In fact, there is a key right above ln that has the e number there. So, just so you know, you can write log with any base you want. But if you were to write anything that has a base of e, they're never going to write log base e. It'll always say ln. Let's look at one more. So I'm going to say e to the x minus 2 equals 3. And I'm going to say, could you convert this into logarithmic form? And if it helps your brain to do this, if you go, you know what, it helps when I say log base e, and then I flip-flop one for one. So wait a minute, I got to put this in parentheses, equals 3. You'd be technically correct, but the kids at math camp, they would laugh at you and say, why did you write log base e? Don't you know we call that natural log? And you don't need kids at math camp hassling you. That's the last thing you need. So this would be the final answer you'd see in our book. Okay. Converting. That's all I'm doing right now. I'm going back from one form to the other. So I did a lot of exponential to log. So how about we start with a log? Like I'll do something like this. Log base 7 of x equals 2. And I go, geez, okay, could I convert this into exponential form? Sure. What's the base? There's 3 things there. Which one of those is the base? The base is 7. What do I do with the other 2 pieces of information? I interchange them. So I'd say 7 to the second equals x. That's it. You've converted. You started with log form, now you're finishing with exponential form. Let's do it again. I'm going to do something like, how about log base OM? Log base M of 2 equals X. Oh, this is going to look kind of crazy, but you know what? If you're all they ask you to do is convert, what's the base? Which one of those is the base? The base is M. What do they want me to do with that? Take it to the X and set it equal to 2. That would be converting. If all I'm asked to do is convert, that's all they want me to do. Base stays the base. The other two things, flip-flop. That's it. Now, there's a reason why we do this, but I'm not going to get into that in this video. I am only going to get into how do you convert things and what are the log properties. That's all I'm going to get to in this video. Then the next video expands on that. But let's just look at one more here. What if they said something like this? Log of 4 equals X. Oh, what the heck? Let's make it fun. X plus 3. And then you say, well, I can't do it. They didn't give me a base. There's no base. Yes, there is. If they don't write in the base number, what is it? It's 10. If they do not write in the base number, then the base is 10. So if it's not written in for you, you assume it to be a 10. So I'd go base stays the base, flip-flop. So I'm going to flip-flop these pieces of the puzzle. And there you go. Hey, let's do one more just in case... Natural log of x plus 1 equals 5. And you say, they did not write the base in. There is no base. Sure they did. If it's a natural log, then it's the same as saying log base e of x plus 1 equal 5. But if that helps your brain, great. But when you convert it, boom, there's your base. E to the 5 equals x plus 1. There you go. So what am I going to ask you to do sometimes? Convert. I'm going to ask you to convert. And one of the reasons why I ask you to convert is sometimes it will help you solve a problem. Sometimes it'll help you solve a problem. In fact, I made one up here without even realizing that you're going to see in the next video. See this guy right here? This is called, in my book, I call these mini, or like miniature, mini log equations. Sometimes they give us something that looks like this. And I go, what the heck? I don't know what x is. I have no idea what x would be. But guess what? If you rewrite it, the base stays the base. You get 7. The other two flip-flops, 7 squared equals x. Well, wait a minute. What is 7 squared? It's 49. So I just solved this equation. See, it's got an equal sign, so it's an equation. Oh, I just solved it, and the answer is 49. How did I solve it? Because I knew that converting is one of the tricks I can use to get the answer. So converting is one of our techniques for solving things. But there's some things that we don't have to convert. And these things that we're going to look at right now are called properties. Now the first property, you guys already know this property without even knowing it. Log of 1. Now I'm going to put it in parentheses because when you punch it in on a calculator, if you go log of 1, it's always going to give you the answer 0, no matter what. Well, what if it's base 6? It's still going to be 0. What if it's base 61? It's still going to be 0. If you take the log of 1, you will always get 0. When something is always true, we call it a property. Proper. Whoop-tee. Okay, When something's always true, we call it a property. Let me show you. Log base, what the heck? Let's do log base 3 of 1. I know it equals 0. Why is that true? Well, why don't you convert it? If you convert it, the base stays the base. Base is 3. Flip-flop. Oh yeah, 3 to the 0 equals 1, because I showed you this in an earlier video. Any number to the power of 0 is 1. Any number to the power of 0 is 1. So whenever you take the log, heck, look, base 61. 61, flip-flop these two. 61 to the power of 0 is 1. It is. Anything to the power of 0 is 1. So our first property for logarithms is the log of 1 is always going to be 0. Always. You take the log of 1 at 0. Why? Because if you were to convert it, you'd see automatically why. You don't have to convert things that are properties. You just have to know them. You'll save yourself a whole lot of time. If you're working on a problem and all of a sudden you get the log of 1 in the problem, well, heck, that's 0. You don't have to justify it. You don't have to explain it to me. You take the log of 1, you know what you're going to get? 0 every single time. So that's our first property. The log of 0, or sorry, the log of 1, I keep saying it backwards. The log of 1 is always 0. It is, no matter what. First property. What if it's a base E? Then I would say natural log of 1 equals 0. That's also true. No matter what the base, okay? It could be any base you want it to be. If you take the log of 1, you're going to get a 0. And all you have to do is convert it into exponential form to see why. But memorize it. Just have it stuck in your memory. Hey, I took the log of 1. It's 0, right? When somebody asks me, how many likes do I get on Facebook? I say log of 1. I get 0 likes on Facebook. Because I'm not very likable, and I have log of 1 friends on Facebook. Think about it. That means I have 0 friends, and that's okay. Let's go to the next property. Here's the second property, and you guys have seen this one in action. All right, here's what it looks like in the book. In the book, it says this: log base A of A equals 1. That means whenever this number is the same as this number, you will get 1 for an answer. When you take the log of 3, base 3, you get 1. If I took the log base 7 of 7, I would get 1. If I took the log of, I don't know, x base x, I would get 1. As long as these two things are identical, you will get 1 for an answer. And you might say, well, heck, how could that be? Well, once again, if you want to know why a property is true, one of the easiest ways to get there is convert it. Take a look at this one, because it's got a little room here for me to work. What's the base? The base is 7. So I'd say 7 and then flip-flop. 7 to the first is 7. Yeah, it is. Totally. It's totally true. See, in mathematics, when something is always true, check this out. When it's always true, we call it a property. So my second property is when these two guys match, when they match, what do you say? The answer is 1. So that goes for natural log 2. Now check this one out. I just wanted to make sure you saw this. Log base E of E would equal 1. That is totally true because these two guys are the same. But you know what? They will never, ever print this like this in the book. What are they going to do instead? Instead, you will see it written like this, natural log of e. Ha ha! See, because this stands for log base e. But second property, when those two guys match, you get 1 for an answer. That is your second property. So you might be working on a problem and you get something like log base 4 of 4. And then you go, oh, that looks overly complicated for no reason. But I know that there's a property that says that's the same thing as 1. It's true. It's totally true. It's totally true. In fact, I'm going to just kind of clue you in on something else you might know. Can't you trick your calculator into telling you what that answer is? Sure you could. If you wanted to trick your calculator into telling you log of 4 base 4, you would say, I want to take the log of 4. But I'm going to trick my calculator into doing it by dividing by the log of that base. And then, hey, remember in math, once you make a rule, you can never, ever break it? You take any number and divide by itself. What do you always get for an answer? 1. There's another way to prove that property is true. So true. Now the next property looks gnarly, but it's super easy too. Let's take a look at it. This is the third property. And then there's only one more. There's 4 properties. The third property is this. Log. I'm just going to write it out. You know what? I'm going to write a couple down so you can see it. See this guy? Log base 5 of 5 to the third. It looks super complicated. It totally does. I agree. But you know what the answer is? 3. How about this? Log base 5 of 5 to the 17. Guess what the answer is? Guess. Just guess. It's 17. Like, if you have this number down here and this number here, they match. You put anything here that you want. That's the answer. Now, I don't know if you guys remember this, but when you take the log of something to a power, what do you get to do with that power? You get to bring it down front if you want. If you want. So let's just examine this. If I did log base 3 of 3 to the 8th, I could say, hey, the power rule lets me bring this down front. If I want, I could say 8 times log base 3 of 3. And then I could say, wait a minute, I just learned this property. When these two guys are matchy-match, I get a 1. So what's 8 times 1? It's 8. But you know what? What I'm trying to preach here, what I'm really trying to get in your head, is if you know something is a property, you memorize it, you recognize it, you own it for life. You know, when I turn 55, I'm going to turn 55 in a couple of weeks here. I'm going to get a candle on my cake that says that, because I know that is a super fresh way to say 55. Because when these two guys match, whatever the power is, totally true, not lying. So what do you think this is? Here's sneaky. Sneaky. Oh, what am I going to put here? How about a -2, just to be really sneaky? Log of 10 to the -2. And you might say, well, you didn't give me a base. And I'm going to remind you again with a red pen, if they don't write in a base, then the base must be 10. So what do you think this special answer is here? This trying to be tricky? It's -2. That's what it is. When these two guys match, whatever this is, and then you go, well, wait a minute. You told me when these two guys match, let me see. You get 1 for an answer. You get 1. Well, if I wanted to, couldn't I do this, like log base 2 of 2 to the first? I could if I really wanted to, but I didn't, because I don't have to write it in if it's a 1. But guess what? Then it wouldn't violate this property, because once you make up something that always is true, we get to call it a property. So let's review. Up to this point, we've got a first property. Whenever you take the log of 1, you get 0, no matter what it is. The log of 1 is always 0. That's property 1. Second property, if these two guys match, bam, 1's your answer. So like that, that's a 1. This is a fancy way to say, what? 1, baby. Oh yeah, that's my second property. Third property is the one that starts to look kind of gnarly. But look, if these guys match and you got a power, that's your answer. These guys match, you got a power, that's your answer. These guys match, you got a power, that's your answer. Super quick. Now the last one looks the spookiest. 2 to the power of log base 2 of 6. But I want you to realize, once you learn a property, you recognize that property, they're super easy. You don't have to do any extra work. Now, you could punch this into your calculator. You totally could. You could punch this into your calculator. 2. And then you'd have to use the caret key to the power of. Then you'd have to go log of 6 divided by log of 2 to trick your calculator into being base 2. You could punch it in, you could, but oops, you'd have to put this whole thing in parentheses. And your calculator, you know what it's going to tell you? It's going to say 6. Because whenever you have a base value, I don't care what it is, 4, if you take it to the power of a log with the same base, whatever's this is your answer. 5. What about now? What's the answer now? It's 52. What about the answer now? It's 520. If these two dudes match and this is your exponent, you get this wonderful chunk of junk right here. It's true. So here, let me throw a curveball at you. What if this was the base and I went like this? Could I punch that in on my calculator? I surely could. And if you don't see that this thing is 4, you still could punch it in on your calculator and it would give you 4 for an answer. But what I am trying to preach here is this. If you know your properties, you can save yourself a whole lot of trouble getting an answer complete because you know that property. Now, I just want to do a quick recap here because there are no practice problems in this. So let's do a little just mini quiz before we go to the next video. And if you cannot answer these questions, you've got to rewatch this thing or you have got to ask me in class when you can. Because if I said, take this problem right here, I'm just going to make one up. Convert that into an exponential statement. You may pause this and then try it. Go for it. Okay, if you were to convert this into an exponential statement, what do you have to remember? Base stays the base. The other two dudes flip-flop. That's your answer if you were asked to convert into exponential form. Let's do one more. What if somebody said, convert this into exponential form? Pause it, try it, and then let's see if you got it right. So pause it. Okay, if I convert this, it would be a base of E, and then the other two dudes would flip-flop. That would be my conversion. So, one of our main skills is, can we convert things? Okay, can we convert things? What if I started you with a statement that looked like this? 4 to the negative 2 equals x. And I said, rewrite this as a logarithmic statement, or convert it. You would have to say, well, wait, I'll pause it and try it. Okay, here we go. It would be log, but what's the base now? The base is 4, because the base stays the base. The other two flip-flop. Bam, that's my answer. All I'm doing is I'm asking you to convert something. What if I was to say something like this? And I said, convert this into a logarithmic statement. Go ahead, pause it, try it, and then unpause it, see if you got it right. Okay, here's the conversion. I'm going to say this would be log base 6, because that's the base. And then I'd flip-flop. Of 4 equals x plus 3. That would be the converted statement. So, the first part of this video was to practice converting. Can you go from one form to the other form? Then the other thing that I was trying to preach was this. And this is how you need to use the properties. Here's how the properties work. You'll be working on a problem. You'll see this next week. Not this week, but next week. You'll see something, and all of a sudden you run into something like this. And you go, oh, property. The answer is 16. You'll be working on something and you will do this. And you'll go, oh, I'm taking the log of 1. That's always 0 because that's a property. Or you'll be working on something and you'll get to this point. And you'll go, oh, log base 2 of 2. What does that equal? That equals 1. If they're matchy-matchy, you get what you got. And then there's this guy where it's something like, I don't know, 5 to the power of log base 5 of 2. And you go, what's that? It's 2. Why? Because it's also a property. And once you know a property, it's yours to have and to hold. All right? So, guys, this lesson, this video, is just to show you how to convert back and forth and what are the 4 properties. And don't forget, these 4 properties, they also work for E and natural log. So this property, bam, that's a 3. Fancy way to say 3. If I did this, ln of E, that's just a fancy way to say 1. Super fancy, right? Wait, I don't get that one. Well, it's log base E of E, ain't it? Matchy match. That's a 1. But we don't write this because kids at math camp would tease us. And we don't need that hassle in our life. Okay? All right. So, this lesson, let's call that a day. We're going to move on to the next one where you will see a lot of practice. Hey, in the practice, there is very little work to show, but there are a couple questions where you will want to use your calculator. So for the next lesson, please have your calculator handy. Okay, guys, until next time.